All right. Welcome, everybody. Has everybody gotten the link or gotten, first of all, connected to Discord? Who here is not connected to Discord yet? Okay, why not? Did you email Caleb? Okay, email him right now because he emailed out the new link. Also put the new link on the syllabus, so it should work now. Now, the other thing that he sent out was a digital document where you can put in your chosen data set. Have all of you seen that? Who hasn't seen it? Raise your hand. Okay. Make sure you do that today, right after class, or even communicate during class.
I looked into the document and it looks like it's a view-only document.
Ah,
So
has anyone been able to edit it at all?
however, I'm
Nope.
not on my Gonzaga email, so it might be like I'm on my Gonzaga email and it's you. Okay.
All right. Let's see. People say the shared doc is view only. All right, he should be giving you edit access soon. If he's not in class right now, he'll probably do it right now. All right, so that's the next step for y'all. But we're going to go around class right now, and everyone's going to say their name and their chosen data set. Let's start here.
My name's James. I think I'm gonna try to make my own image data set,
What kind of images?
probably JPEG or PNG.
But the images of what?
I haven't decided the object, but of a specific object that I'm trying to. I was thinking maybe like my car keys.
Okay,
Yeah, something like that. Yeah.
all right. Whatever you choose something today.
Okay.
I'm Jack. My plan right now is to do my screen time data, but I'm having trouble finding a way to download it. So if I can't end up downloading it, then I'm gonna do my ancestry.com data.
Good.
I'm John, and I'm gonna do my Apple Watch.
What part of it?
All like walking steps, walking, heart rate, calories per
Nice.
My name's Jack, and I'm going to do different affairs. I will say.
All right. You have family there?
Yeah, that's right.
All right.
I'm Dom, and I'm doing ski resort data. So like acreage, location, and relative to other resorts.
Austin, I'm doing steps on my watch.
All right. Over here.
Andrew and that maybe probably 19 students in the
Okay.
Yeah, I'm gonna do like the 10 CD.
All right. For how many years?
So like always like 30 years.
Okay.
I'm Henry. I'm gonna do like top stream movies or TV and see if it adds up with what I want to.
On which services do you think you could get?
I was looking earlier, like this one website had every service, but it might be easier to do like Netflix.
Yeah, because you can get every service. Nice. I didn't know that was public.
My name's Hoover, and I'm going to do my
All right.
My name's Asher, and I'm also gonna do this. Or maybe my YouTube history. I haven't really decided what to.
I'm Nick. I've been compiling some game logs for starting pitchers from the BS season.
All right.
Which I'm gonna be using college as
And Gonzaga included?
I'm Ethan, and I'm doing this on like daily transaction data.
On what kind of transactions?
I mean, you can like I have data into how many swipes a day, and I get every 15-minute interval.
Like in the whole world?
Oh, the clock,
The clock. What is the clock?
it's So I understand.
All right.
American, I'll do my list, like, listening.
Which service?
Apple Music, and SoundCloud.
All right. Adaptability. Does your computer make that for you already? You have to install some. Make sure you can. So what you guys want to do is you want to know that you can get this data. Maybe even have already looked at some of it. All right. Well, have you ever looked at those GIS plotters, those free software to plot things like earthquakes on the globe and see it? Crypto. What about like the price of things? You have a favorite toy? What is it? Ethereum. Excellent. All right.
I'm Louis, where we work on the same project.
But you can't go all the way back. 99 as far as you want to go back. So you can't get back to the John Stockton days. Yeah.
I've been doing soccer teams, aggressions, and fouls.
Red cards.
Yeah.
Nice.
So I'm Ravon. My data set is images of berries, birds, logs, flowers, write programs to determine what type of berry is this, or is it even a berry?
Excellent. Have you figured out which model you might use?
Yes.
Well, YOLO and Ether are both good ones. All right.
I'm Arjan, I'm doing global video game sales since 1984, and it gives the regional information. So I find like the per genre in different regions.
Is ColecoVision on your set?
Is what?
ColecoVision. It would have been around 84, so that was my favorite at that time.
I mean, I'm sure it's on here. There's a lot of entries, so it could be.
They were the best in the world for a while, then they went out of business. Like so many back then.
My name is Vanessa, and I'm looking at it's the million something data set. So essentially, it's like what's of all of these songs and then coding it to determine whether a song is hit or not.
Mm-hmm. Which features of each song?
I don't know yet.
Make sure you guys look at the data today.
Cody, and I'm going to do my spot.
I'm Luke, and me and Jake are gonna work on electric vehicle data. We're not too sure on what we're gonna try and see what trend, but
Mhm.
there's a lot of data.
Maybe like regional boards, seeing like what's most common where,
Mhm.
seeing the growth rate. I mean, we got like, there's like another like file with like transaction titles as well. So there's a lot of stuff.
It's just for the state of Washington.
Okay. Nice.
I'm gonna be working on Alzheimer's disease and healthy aging data. The .gov.
Important stuff.
My name is Miles Mercer. I'm going to be looking at text files of the scripts for the original 3 Star Wars movies and doing sentiment analysis.
Excellent.
Okay, so my name is Bill, and I try to check some data for like a soccer team called Young Grade, and try to find like about translating the text.
I say what?
I don't know, just like I learn the data, I just like
Mhm.
I don't need to gamble yet, just like that when you go
Yeah.
to stores.
So I lived in Madrid for 2 years and I didn't know anything about the local soccer team. So I moved there and I happened to become friends with guys who are Atletico Madrid fans, which is like they're not nearly as good team. But I didn't know. So my loyalty got stuck into that. And then they did so poorly, they got knocked out to the next league. What's that? You, awesome. All right. So everybody put your data set description in that document today and get your eyes on some of your data. Download even just 1 day of it or whatever. Make sure it's even possible.
That's just an Discord.
The Discord might have a link to it. Let's see. Yep. Yep. You have to scan up a little bit. It was posted yesterday. Did you guys finish with the attendance sheet? No, got stuck, right?
Yeah.
It gets stuck back there. It's on its way.
But it is our first.
Does anyone need more time for entering your data chosen set? No? All right, then everyone get out Google Colab. And then you see this cell here about importing polars as PL. When you do that, you run that, and you'll probably get an error. And tell me what your error is. What error did you get? Yes. Does anyone know how to solve that?
Exclamation mark pip install polars.
Exactly. Very good. And it looks like that. So everybody do that. Now, on a normal command line, it's just pip install. But a Python notebook is not a normal command line. A Python notebook is meant to just interpret Python commands, whereas pip is something outside of Python. Pip installs the modules, manages the modules for Python. So the way you get outside of Python from inside Python, at least in a notebook, is with the exclamation point. All right, does anyone need more time? All right, now, first of all, if you've been able to read it into that df variable, this is a data frame. A data frame is just something that can hold all of the stuff in a typical CSV, all of the columns, and it knows what those columns are called. And what we're going to do is we're going to take one of these columns and we're going to filter on that column. First of all, you can choose the column that I chose and do exactly what it did there. And then you're going to do the same for a different column, whichever one you want to choose. You can filter by something equal to something, or if it's greater than or less than. But first of all, do that next cell and see if it works. What's that? Yeah, each one of the little code blocks is itself. So the next one is the filter df equals df dot filter.
So data carries over between cells.
So it does. The variables, if they have been run recently enough, the variable contents carry over. So above, we defined df as everything that was in that CSV, but it's now been parsed into a Polars data frame, which is a useful way to interact with that data. It's an object that knows where everything is. And that object has methods or functions on it. One of them is filter.
This PL.col.
I think it's a collation, but PL is the Polars package, and COL is just one of the functions that's in that package, can be used for all kinds of things. And I think it's column. I think COL stands for column. But everything inside of the filter thing, what that means is it's only looking, it's going to filter out all the rows that don't match what's inside the parentheses. And in this case, it's going to be population greater than 10,000. But yeah, I think COL stands for column. And that dot, that Python dot, hold on, it can mean two things. Sometimes it is the function that is inside of an object's definition. Other times, it's just a function inside of a package. And this time, pl.col, it's just a function inside that package. But for the df.filter, filter is a function of the data frame object. Okay, your question? Yes, I think you can. Yeah, I think you would just separate them by columns, by comments. But I haven't tried that yet. I don't keep all the syntax in my head, but I try to keep an idea in my head of what's possible. Maybe you would separate them with a double ampersand, actually. I think there might be a separate function called COLS, which might allow that.
So when I'm playing with it and I reduce like the number 10,000 to 1,000, for
Yep.
example, I get a lot more entries, like 9
Yeah.
entries, but I don't get any of the ones over 10,000. So all those entries are
Well, show me.
gone. So I have 3 entries right now, and if I just go to this here on this,
You actually, they might be in between. So if it's too many to print out, what pullers will do is there will be a row that just says dot, dot, dot. And that's hiding a lot of them.
Okay, is there any way to expand that?
I can't remember right now, I'm sure there is.
Okay.
Typically, if you want to see every row and not just a summary, you want to go through it row by row by row. And there'll be a way you can do a for loop. That'd be a good thing to look up to learn how to do. Sure. It might be called inter rows, but can't quite remember right now. So when you just print it out, it's calling a function. That function print is defined in Python for the base level things like integer and string, whatever. It wasn't defined originally for this brand new polars object. So what Python does is Python looks to see if polars, the very definition of it, has a way to print it internally, and it does. And what it does, one of the things it does is this summarization. It will shorten things. It also shortens things if you have too many columns. You'll see some of the columns in the middle aren't represented. You have this is dot, dot, dot. So it's trying to save space in multiple ways. All right, so I want you guys all to choose a different column and a different value and filter on that and print it out to your screen.
How would I do like a range? If I want to do like between
Oh.
1,000 and 2,000.
These are all good questions. And you should look it up tonight. We'll do a little bit more each class.
Okay.
These are all very good questions, but yes, you can do ranges and there's ways to do filtering on multiple columns at once. All right, everybody ready? All right, well, we're going to try to finish chapter 1 today. All right. First of all, how many of you haven't finished reading chapter 1 in Zybooks yet? You've all finished chapter 1? Good job. All right. So we talked last time about the case where you have 3 ATM machines and how we can't have all 3 things at the same time. If you have a partition, this machine can no longer communicate with the rest of the network and presumably the servers at the bank. So therefore, either you're just going to say, hey, it's not going to be consistent, or it's just not available. Can't have all 3 things at the same time. And this is why some data has to be in a database that is ACID compliant. For big data, this is not important. For instance, if you have a lot of people sending their heart rate on their Apple Watches into a giant database, you want to analyze huge populations. If there's a little update right now or later, or this minute or that minute, it doesn't matter too much because you're looking at large data in the aggregate. And whatever your heart rate was yesterday is never going to change. Whereas the amount of money you have in a bank account is going to change. CSVs, we looked at JSON, we looked at XML, we looked at. Have any of you chosen data that is in XML? For the Apple Watch people, I think you have choice, right?
I think so. Yeah,
I've seen some devices spit out XML data, even recently.
yeah, they do.
All right, well, you're gonna have to use XML. And XML eTree is a good Python package for reading those. There are some packages which seem to be easier to use, but they forget some things and skip some things. Let's see. For instance, inside of a tag, you can have attributes. Some attributes have values, some don't. Some, I think it's even optional. There are some Python packages which won't get all of that. Now, if you don't care about those things, then that's fine. But if you care about everything in there, you might need to use XML eTree. All right. Who here has seen box and whisker plots? All right. Can you tell us what this part means?
So that would be from the minimum value within 1.5 interquartile ranges of the Q1, yeah, Q1. The dots are outliers, so we don't count them as the minimum, but it would be the first minimum that would be considered.
This one right here?
Yeah.
Yeah, the other way you think about it is the variance, right?
Yes. For the whole thing?
This from here, the whisker part, all to here. So if we have a bunch of data,
Like variance is a quantity for a data set.
yeah, so if you figure out what the variance is, I think this plots the variance.
Yeah, it shows what might be expected in that range.
And I believe this is the median.
bottom, in the left-hand box is the lower close. The most treated below the median. The box on the right-hand side is the most treated above the median.
Yep. And it's a very intuitive way to get a feeling for your data. How wide the ranges are. If you have just one variable, let's call it X, and you have a bunch of data that happens to be normally distributed, this will be your mean, and actually it might also be your median as well. But variance is some number that gives you an idea of how wide this range is, something like that. It's a good thing to look at your data, get a sense of how much variability there is in it. And the box in which you're plot is just a nice way to do that, and it's typically easy to do in Python. So yeah, your minimum, maximum, upper quartile, lower quartile, and median. Scatter plots, also really nice. Now here we have bill depth and bill length. Those two things, the dimensions of the bill of this penguin, make it pretty easy to analyze and say, hey, these are pretty much clear to us. So if we were to have a new creature we come across, and we measure these two things, the bill depth and the bill length, we can plot them somewhere in here and say, hey, this one's probably in Adelaide. And up in here, this is probably a chin strap. And this is probably a gentoo. Now it's really difficult right along the edges. And there are some outliers, like this guy right here. And why would bill depth and bill length be related in that way? What is the thing that's being preserved?
The species.
Yeah, but that's like behind the scenes. If you were to think of bill depth and bill length and look at the way things are scattered, there is a feature that's being preserved besides species. Something that involves the two features. What is the variance or what is the invariance? Nope. It's a ratio between the two of them. So if you looked at bill depth over length, you get some value in here. And you get a slightly different value in here, and a slightly different value in here. Now, what's interesting is we don't see gender on there, we don't see age on there. Presumably, as you get older, maybe their bill length grows, but the bill depth grows with it, right? Maybe it's the ratio that's preserved between the two. This is a case where a biologic pattern where both dimensions grow maybe at rates that are proportional to each other. That's the underlying mechanism, and it can be seen in the data. And that's why they cluster the way they cluster. Whenever you're looking at your data for your project, it's a good idea to understand what are the underlying relationships between these things. For those of you doing the Apple Watch, maybe you have number of steps per hour and your heart rate. Those two things should be correlated. If you're running instead of walking, your heart rate will go up. Those are exactly the kind of things I want you to write about in that report. In the final project at the end of the year. But you would start working on it now. Okay. If we were looking at just bill length, and we had data come in that's exactly 38 millimeters, puts us right in here. Very obviously, very likely to be Natalie. We hope it's not an outlier. What could help us ensure it's not an outlier? More data about that one individual. Yes. What other features?
Minimums on the skirt box.
Well, we have that right here. If this is a new creature, of course, the other features about that one animal, as compared to all the rest, will help us figure out. Because bill length grows over time, it might just be a very, very young gentoo, right? Because presumably their bills all start at a 0 when they're cells. So you almost never want to look at just one feature. Now here's body mass and flipper length. This is a regression model. What kind of regression? Linear regression. In which case we assume that we only need 2 numbers to model the relationship between those features. So the M and the B. So here, Y is body mass and X is flipper length. So for any flipper length, we can get what the body mass should be. And of course, it's approximate. It's not exact for anybody, really. Does anybody know how we get this line? There is always a perfect answer. What we do is we add up the squared errors. Let's say this is our line, and we have a bunch of dots. Everywhere the dot is not exactly on the vertical line, we draw a vertical line there. You can just use packages that do this for you. Scikit-learn has them. The idea is you want to minimize the sum of the squares of all of these. This squared plus this squared plus this squared. Sum of the errors squared. Why would you want to square it? Why not just sum up all the errors? Some of the values would be negative. Exactly. Now, is this better than just summing up the absolute value? Because that would handle the negative thing too, right? Why not do that instead?
You really don't want huge errors, and so starting makes that relationship hard.
It punishes the bigger errors more, doesn't it? Yes. That's right. So if you have huge outliers, like 1 or 2 really bad outliers, if those outliers were to down like that, that would push the whole line significantly down to minimize this. These 2 would have more effect on the line than the others would. So that's probably a good thing. That may not be what you want though. You may decide, hey, I just don't want to handle outliers. They're weird. I'm not going to model the weird outliers. I'm just going to model normal behavior. It just depends what you're interested in. So yes, the normal linear regression uses squared errors. And mean squared error is what they call it a lot of times. Mean absolute error is if you use absolute values. Depending on which package you're using, they might have different names. But scikit-learn and in PyTorch and TensorFlow, these are all common ways to make something fit your data. In this case, we're just doing a straight line, but the same kind of thinking applies to all kinds of curved lines. All right. Now, this says unsupervised models. What do you think that even means, to have unsupervised? Whenever you're training your machine learning or your learning system, you got to teach it with examples, right?
Does it like mean, it tries to correlate the data itself, basically?
It is trying to do something itself, yes. In this case, what do you think it's trying to do there?
Well, it's trying to determine if the penguin is big or small, or large.
Yeah, well, we as humans, we can call them large and small afterwards, but what it's trying to do is look for a meaningful break in the data, right? Like the ones on one side, we know they're bigger, these are smaller, but we end up calling them.
So it's trying to make two kind of categories.
Yes,
Two groups.
trying to make categories. Now, sometimes you know ahead of time how many categories you want. If you just want to do something binary, you can say, I want big ones, I want small ones, whatever. Or you can say, there's 5 kinds of people in the world. And I'm going to split everyone into those 5 groups. So you're going to decide K equals 5 and just cluster people accordingly. Have you guys heard those jokes? There are 2 kinds of people in this world. Or 3 kinds of people in this world. There are 3 kinds of people in this world. Those who can add and those who can't. Ha ha ha. There are 2 kinds of people in this world. Those who can fill in the blanks. Pretty funny, haha. Now, here's a harder one. I want to see if you get this. There are 10 kinds of people in this world. Those who understand binary and those who don't. Yeah, fine. So if you know how many groups you want, then you can use one of these systems that imposes that reality on your data. If I know there's going to be 2 groups that I care about, I'm going to impose that reality, say, there's 2 groups, find the clusters. And it will do its best job, the best it can, at separating your data into 2 meaningful clusters. What if you don't know how many there should be? Have you guys ever seen a clustering method that can do that? So there are clustering methods for this, and I prefer them. Now, if you can look at your data and you see something like that, then it's great. You can estimate how many you think there should be. But if your data has not just flipper length and body mass, but it's got bill length and this and that and maybe 10 features, that's 10 dimensions. And you're not going to be able to understand those 10 dimensions unless you do something with it. So there is something called HDV scan. which I like. And you can just use it, it's in scikit-learn, I think. But what it will do is it will do a pretty good job of finding clusters for you. And they can be really weird clusters. They can have different densities. And it can see some strange landscape and figure out, okay, this is a cluster, this is a cluster, this is a cluster, this is a cluster, this is a cluster. And if you want to go on a deep dive, you can also look up something called UMAP. UMAP and HDB scan are really good at taking data that's in high dimensions. It could even be 1,000 dimensions, and figuring out the lay of the land for you. How is it organized? What are the meaningful clumps? And this is so useful in higher dimensions than you can think. We need coping mechanisms because we are not able to instinctually do it. But this kind of clustering, or sometimes what we do is we bring it down to lower dimensions beforehand, and UMAP is really good at this, and that's called dimensionality reduction. Bring the dimensions down. Whenever you look at a map of the world on a flat piece of paper, someone has done dimensionality reduction. Because the world is a 3-dimensional sphere, right? Someone has brought it down to 2 dimensions for you. Any questions? All right. One of the common things out there that people talk about in machine learning is fraud detection. And actually, I think we talked about this. What makes it so hard to do fraud detection? If you just have a stupid model that just says not fraud, right?
I was gonna say you have to have some argument, not just fraud, you know. That's a very case.
Yep. It's one of the harder things to do because you don't have enough examples to learn from. Well, it turns out that models that work well, pretty well in that space are things like random forests, and XGBoost. These are models that are able to handle situations where you don't have much data for the class you're trying to find. But they also tend to overfit easily. Who knows what overfitting means? Let's pretend I build a model for just this class, for you guys. And I'm trying to predict whether or not you like the movie Napoleon Dynamite, let's say. Who here has seen that movie? All right, we'll talk about it again at the end of class. Let's say I ask you questions about everything except Napoleon Dynamite. I ask you about other movies you've seen, how you rated them, what you do for fun, what your other hobbies are, what music you listen to, and I get a ton of features, and I get them all to the point where in this class it's 95% accurate, but I want to get perfect. So I keep asking you more questions. And every question I ask you, like, what color is your cat? How many siblings do you have? How many hours a week do you spend exercising? Even though those things may not have anything to do with your opinion on Napoleon Dynamite, eventually within this class, I will have asked enough questions that I can use those questions as input. And I'll be able to put all of you on the yes or no, I do like this movie category. And that will have a perfect classifier that's 100% accurate for this class. Now, if I use that same classifier for some other randomly selected group of 30 people, it's probably going to be really wrong. Because it depends so strongly on the idiosyncrasies of people in this class. But it's not really a generalized model that applies to the whole population. That's what it needs to overfit. So for random forest and XGBoost, although they do better on fraud than anything else, they can also overfit. So you have to be careful, and you always have to be checking cases. You have to have humans look into the cases. And maybe on the ones that you're not sure about, you lean toward fraud. Assume fraud and have someone look it up. Have someone check in. A human in the loop. All right, who's heard of GDPR? In Europe, they have laws around your data. You have the right to forget. The government of the European Union forced Google and Facebook and everybody to do this so that for a European customer, if that customer says to Google, forget everything you have on me, my browsing history, the cookies, advertising, everything, Google has to promptly do it within 60 days. They might not actually do it. I don't know. I don't know how they could even check. And if they didn't do it, maybe they store information about those Europeans somewhere in California. I don't think European countries have jurisdiction on the servers in California. So could they even check? I don't know. But I know that by law, Google has to do that in Europe for European users. Supposedly they do. Facebook, same thing. Does anyone remember the Cambridge Analytica disaster? What do you remember about that? Who wants to tell?
It was the Facebook. They got me too much information and basically helped with, right? So people who weren't supposed to have information use information.
Yeah, well, people at that company specifically had information they probably weren't supposed to have. Somebody obtained it, I think, for educational or research purposes, and they got their hands on it.
Didn't it allow like targeted, like, didn't it allow like people to get targeted for like the opinions?
Yes.
Motion.
Specifically people who are in the middle or undecided. And some people credit it with throwing the election in a certain direction. Some people say it was such a small thing and couldn't have done that. But Cambridge Analytica, they take credit for it. In fact, there's footage of a sales meeting where they're talking about not only how they pushed the American election, but they've secured other elections, such as in African countries. And I literal sales pitch saying, you know, if you get us on your side, hey, we'll throw the election whichever way you want. Just tell us. That's a lot of power. Data has a lot of power. My hope for your generation is that you learn to ignore that kind of stuff and don't let yourself be too swayed. But for the older generations, there's probably no helping us. Who has heard of CCPA? It's the new California laws that are kind of like GDPR. And if a company wants to be on the internet and have customers in California and not get sued by the Californian state legislature, then they will comply with CCPA, which means probably everyone in the US will. And just to make your lives easier, why not comply with GDPR and CCPA at the same time? This is going to mean that as you guys grow up, you're going to have a little more control over your data. You're not going to have to worry just about everybody knowing everything about you for the rest of your life. But there will always be people who don't comply with these. So if you do something stupid and it ends up on the internet, it will probably be there forever. So be careful. Okay, anonymization. Everybody knows what that is, right? Anonymization of data. Does anyone know what re-identification or de-anonymization is?
You have all the data right there, so you just say, oh, well, I'm gonna figure out which is this person's data.
Yes, and this has been done for medical data. How is that even possible? How do you think they do that? One of the things about medical data, which is really hard to resolve, is the fact that if we shared everybody's medical data with everybody in the world, we'll probably cure 10 more diseases this year. But then we all lose privacy as well. And in this country, at least, and in Europe, we've optimized for privacy. And we protect medical data with so many hurdles that it's really hard to get at it and do something useful with it. HIPAA is the standard for dealing with medical data. And it means that if you're going to have access to people's medical data, if you work at a hospital or a health insurance company or anything else like that, then you have to sign a bunch of documents and you have to be super careful with the data. And I've worked at a company that did AI on medical data. And in order to do the actual machine learning work, we had to get on a VPN, log into a Windows machine, then from that Windows machine, open a shell to another machine, a Linux machine. And that's where we could actually do the work, but the data wasn't actually there. We had to request something, and some other person in some other office would put some data on that third machine. And as you can imagine, it's not easy to program that way. It's not easy to try things out. When you're doing machine learning or anything else interesting in computer science, you are going to do it wrong the first 100 times. So you have to do it again and again and again. And dealing with medical data is so hard. But it's partly because anonymization isn't good enough. There was an early data set, medical data, that was anonymized, totally anonymized. Every person's name was replaced with some random number. And then some other group was able to cross-reference that with maybe census or tax records or something, and they were able to figure out several of the people in that data set, tie them to their name, their social security number, and supposedly it was because of random small things that could cross-correlate. Like maybe they had, they were older than certain people in that state, and we knew exactly when they were born. We knew maybe a couple things about their health that were very rare. And if you look at, who has this rare feature and this rare feature, and eventually, sometimes there's just one guy in the whole state who has 2 or 3 rare things. So they were able to de-anonymize it. All right. What's going wrong here? What is wrong with this picture?
Basing whether or not they were nerd on the.
Yeah, or the gender. Yeah. This kind of stuff has happened. AI ethics is a big deal. If you have a machine learning model, what can it be trained on? The past, right? And the more of the past you bring in, the more prejudices of the past you bring in. This is a very hard problem. People have tried to solve it by just, maybe hiding the name. or hiding the gender, or hiding this or hiding that, but other things still leak in. There was a model that was trying to automatically determine whether someone should get a loan or not. And they took out everything having to do with name or race, and it was still mostly racist. And it turns out it was looking at the zip code. And people still lived in segregated neighborhoods. So this is an active area of research. And it's a harder problem than you think. And we still should use machine learning. That's what I believe. Even though machine learning can be, you can be subject to prejudices, we have to figure out how to fix the machine learning. It's still a useful tool. And the case that convinces me is that humans aren't very good at this. There was a program that was used to determine whether someone should be given parole. And we think, oh, that's dangerous, you know? But the humans weren't doing a good job either. They looked at a lot of years of human data where you have human parole boards, where what happens is a person comes up and you listen to the case, they're asking for parole, and the parole board says, yes, you can have parole, or no, you got to go back to jail for another few years or another year. Well, they looked at what features were most predictive of whether or not the humans were going to say yes or no. And this is a way in which humans can be checked by statistics, right? Can anyone guess what was the #1 feature? The most predictive feature. If you looked at this feature, most of the time you could guess whether a person was going to get parole or not. Age? No. Yes. No.
Like religion,
No. These are all great guesses.
severity of the crime.
Nope.
No.
Income level?
Nope.
Family,
What's that?
family history.
Nope. The #1, yep.
Good.
Nope. The #1 feature was how many minutes had it been since the parole board had eaten. If they had full stomachs and felt good, they were very likely to say yes. If they were very hungry, they were very likely to say no.
I heard about something similar with like college admissions, actually.
Oh,
Yeah.
I bet. When you guys apply to grad school, send a snack in with your. Never thought about that, but that's probably true. What's that? Yes, or I don't suggest you bring snacks when you do interviews, but maybe it'll help. Bring donuts, maybe. All right. Now, in this case, you have a classifier. You've got a bunch of inputs and it's trying to output a classification, yes or no. But remember, I also talked about something called modeling, in the sense where you have a mathematical object that can do something, right? And it acts like the thing in the real world, right? Well, think about the way your eye sees. You look out into the world and you interpret these photons that are hitting the back of your eye. Nobody can see exactly what their eye actually sees. You see the cleaned up image presented to your consciousness. No one fully understands this, but we have like 6 sections of your brain that are doing different parts of the vision picture, you know, everything having to do with vision. But one of the things is that when you see something from far away, you can guess what it would look like if you see it up close. Look around the room and look at some tiny little part of the room. You can guess what it will look like if you were to walk right up next to it, look at it real close, right? Now here's another funny thing. Look everywhere in the room, especially like ceiling tiles, these things you never touch, or that corner there, or that corner over there, or these blinds. Not only do you know what it will look like, if you were to get up close, you probably also know what it would be like to lick it with your tongue. Why? How on earth would you know that? Does anyone have a guess? What did you all do for the first 3 months of your life? You stuck everything you could in your mouth. Toys, whatever you found on the floor. I have a daughter and I watched her go through this stage. Everything just, every toy is like spend more time in her mouth than she was playing with it. During all that time when you're very young, you're training your neural networks, the networks in your brain, to do just that perception problem. The photons hitting your eye are turning into a model in your head of what this thing is. You also probably have an idea in your head of what it would sound like if you were to bang on the wall or on part of the ceiling or on the vent or even on this projector. Without touching it, without ever going to it and actually doing it, you have an idea in your head what it would sound like to bang on it. You have a model in your head what things are like. Now, a lot of AI models are like that. Maybe they're not going to give you a classification, but remember, they're going to act like the thing in the real world. And let's think about that concept of seeing something far away at low resolution and then getting close to it. And then imagining what it would be like when you're really close. That's called upscaling. Taking a low res image and turning into a high res image. Upscaling. Well, here is an upscaling scenario that showed us something about the model. I think we all know who the original image is of, right? Does anybody not know who that is? Okay, it's President Barack Obama. And when they ran the upscaling model on his image, we get some random white guy. Why did that happen?
The scale was only giving examples like guys.
Mostly white guys, yeah. Most of the visual data out there is white males because I don't know, maybe the machine learning data scientists who are doing it, most of them are white males historically. This is another way in which AI ethics can mess with you and you may not even know what's going on. One of the many problems your generation will have to solve. Just to give you an idea of how these work, this is a typical visual model, very simplified. But you have some input, some image, and you have a convolution. Convolution is where it's going to scan the image. It's going to take a little window and bring that window all across the image and look at all the different parts of it. And it's looking for things like corners and edges and little circles and gradations. And then it brings those together. We call this step pooling. But it's kind of like aggregating what it has found. If it has found certain kinds of edges or corners or gradations or curves and circles. And then it'll do it again and again and again and again. And then at the end, you have basically another deep neural network that's going to be producing some answer. And if it's a classifier, like one of you has suggested using YOLO or Teacher, those are two models that do this kind of thing. And they will give you an answer like whether or not it sees a bicycle or a van or a truck or a car or a person or a cat or a dog. And they will also generate a box saying, I saw it within this box. And if you have some kind of, animal, and you have, let's say, the real box is this. And some model says, yeah, I found a cat and it's right here. It's not perfect, but it's probably good enough for what you're doing, And the way we judge this is the intersection of the two boxes over the union of the two boxes. And when you get it perfect, it's a 1. The intersection is exactly the union of the two boxes. All right, this is one of the things that Facebook is trying to do for all you guys, or Instagram, or whoever else it is, TikTok. They want to have a model of you, of how you act. And they look at millions of these. And if they have an actual model of you that will work the way you will work, then they can test it. They can test what you will do in given situations before they actually do the thing. Like if someone wants to put out a video on YouTube, let's say you make a bunch of choices about, should I keep this chapter? Should I not keep this chapter? Should I shorten it? Should I add captions? Should I not? Should I add this music or that music? They can test out all those versions and see which ones would probably do the best, and then publish it. Or sometimes they'll even publish different ones at the same time and see what does the best. There are a lot of YouTubers that actually have several different thumbnails that they're trying out, or titles. And they do what's called A/B testing. Try, option A or option B. Or maybe they have 10 options and they're going all at the same time. They see which does the best. And then sometimes you come back to the same video and it has a different title and a different thumbnail. You guys are all packing. I guess it's time. Thank you, guys. See you next week.
It's